Hi everyone, I'm going to go ahead and get started with the review on radical and irrational properties. Now, what is the difference between a radical and a rational to begin with? A radical has a value underneath the radical sign itself and has a root or the index and has a power on the outside of the entire thing. The power can also sometimes be under the radical as well. A rational has no radical sign, but it does have a fraction. Typically, we'll see it as a fraction, as an exponent. It could be a whole number, which any whole number can actually be written as a fraction. Like if it was a to the 5th power, then you could do 5 over 1. But radical, rational, radical has a radical sign. A rational does not have the radical sign. Now we can convert one to the other, and we'll be doing some of that today. So let's go ahead and get started with the problems that we had in class. Now, on numbers 1, 2, and 3, they are asking us to find the real nth roots. This is when we talked about how it could have a plus or minus in front of it. When it has a plus or minus in front of it is if the index is an even number. We're going to consider plus or minus. If the index or the root, either one, if the n value is an odd number, we're not going to consider plus or minus. We're just going to stick with the sign that it came with. So looking at number 1 here, I have an even root with a positive value, and I'm going to write that in radical form. So I have 16 as the radicand, and the root is 4. I'm looking for some number times itself 4 times that will give me 16. So what number could that be? Well, we could consider 1 times 1 times 1 times 1. We could consider 2 times 2 times 2 times 2. And I'm doing this on purpose this time so you guys can see this going forward. We could consider all 3s. We could consider all 4s. We could consider all 5s. And I'm going to look at one more. And we could consider all 6s. Now, it's some number times itself 4 times, and I wanted to do it this way on purpose because I want you to see that that number itself is not going to be 1 times 1 times 1 times 1, because that would only come out to be positive 1. So it's not even going to be 1s because we can see it's not a 1 underneath the radical. The next one we're going to look at is 2 times 2 times 2 times 2. That there does give me 16. Now, I wanted to talk about why I know it's not 3 or 5. And the reason of that is this is a even number. The only way that I can get an even number is for an even number to be multiplied by an even number. Well, 3 times 3 times 3 times 3, that's going to give me 81. 81's an odd number, so I know it can't be that one. Okay? If I was to do 5 times 5 times 5 times 5, well, first off, that's going to end in a 5, and it's also going to give me an odd number, so I know it's not going to be 5. Same reason why it wouldn't be 7 times 7 times 7 times 7. It's because that's going to give me an odd number, and I'm looking for an even number. So I would only consider 2, 4, and 6 in this case. And again, it is positive 2. However, I also want to check to see if this can be a negative 2. So can it be negative 2 times negative 2 times negative 2 times negative 2? And yes, it can be, because a negative times a negative makes a positive 4. And this negative times this negative also makes a positive 4. And those two together make a positive 16. So when we're taking the even root of a positive number, and they're asking us to find the real solutions, it could be a positive or negative value. So this one could be plus or minus 2. All right, now on number 2, they're asking me to find the second root of negative 49. So I have an even root and a negative number. Well, I need to find two numbers times itself that would give me 49. My first thought is -7 times -7. But a negative times a negative makes it a positive. So what if I thought of -7 times +7? Well, now they're not the same value. So that is not the rule for taking the square root. It has to be the same value. So this one here, there is no real solution. You cannot take an even root of a negative number. All right, on number 3, where it is an odd root and a negative number. So I am looking at -729, and I'm looking for the third root of that. So some number times itself 3 times, that would give me -729. Well, I know it has to be a negative because a negative times a negative is a positive, times another negative is a negative. So if I'm taking the odd root of a negative number, my answer is going to be a negative value. If I was taking the odd root of a positive number, then my root would be, or my answer would be a positive value. So when you're taking the odd root, just keep the sign, whatever that sign is. If it was negative, keep the negative. If it was positive, keep the positive. So the number times itself 3 times to give me -729 is going to be -9. All right, so let's go on to our next one. So number 4 and number 8. These ones here we are going to evaluate without technology. They are currently a rational because they have a fraction exponent. We are going to convert them into radicals and use our brains, use our knowledge to come up with to evaluate these using radicals. So first, let's write it as a radical. So just like you have the roots of a tree that grow underground, the root of a rational is the number on the bottom. The number on top is the power or the exponent. Okay. So I am going to have 81 to the 4th root and to the power of 3. Okay, the 4th root of 81. Now, if you don't know the 4th root of 81, do you know the square root of 81? Well, that would be 9 times 9. So if I had 9 times 9, and I broke that apart even further, so that it's all the same value, that would be 3 times 3 times 3 times 3. That is the 4th root of 81. So I would have 3 to the 3rd power, and 3 to the 3rd power gives me 27. Okay, now on number 5, let's go ahead and write it as a radical. So I have 64. The root is 3. The root cannot be negative. Okay, so that has to be a positive 3, which means the power will be -2. Now, there's multiple ways to work this one out. I'm going to go ahead and start by simplifying what's in the parentheses. So when I do that, the cube root of 64, it's an odd index and a positive number. So thinking about from the last slide, that is going to give me +4. So I have 4 to the -2 power. We cannot have a negative exponent. So we're going to consider the negative exponent property, which I've listed right here. Okay, so we have to take this value of 4 -2, and we're going to place it in the denominator of a fraction, because currently it is a fraction. It's over 1 when we think about it that way. So when I rewrite it, I'm going to place that in the denominator. So it'll be 4 to the +2, or 4 to the 2nd power. And I have to place something in the numerator. The only thing left remaining there would be 1. And this simplifies to 1 over +16. All right, let's go ahead and go on to the next slide. Here they're asking us to find real solutions. When they're asking us to find real solutions, that's when we have to consider if there's a plus or minus involved, okay, a positive and a negative solution. Now, one of the things that we talked about in class is that if we have a squared and a square root combined, it's going to create the square root of a squared. Now, the square root and square, or if I had an index of 2 and a power of 2, they cancel out, and all I'm left with is the value that remains. Okay, so here I want to know what is the 4th degree touching. What is the power of 4 touching? It is only touching the x. So I can go ahead and get rid of that 2 by using the inverse operation. So I'm going to divide this side by 2, divide this side by 2. So I am left with x to the 4th is equal to 625. Now to undo an exponent of 4, I'm going to go ahead and take the 4th root. Now because I'm taking an even root, that is going to mean that I'm going to need plus or minus, looking for my real solution. The 4th root and the 4th power, they cancel each other out. So I have x is equal to the 4th root of 625. Now if you remember me saying the only way I can get to something that ends in 5 is by multiplying 5. So the 4th root of 625 is plus or minus 5. On number 7, here on this one, I need to look for, or get into x, but x is inside the parentheses. So before I can even unpack the parentheses, I have to get rid of what's outside the parentheses. So a degree of 5 will be undone by radical 5. Now on this one, I do not need plus or minus because it's an odd degree. So I am left with x minus 10 is equal to the 5th power of 243, which happens to be 3. Now I'm going to add 10 to both sides. And I get x equals 13. Okay? All right, before I go on to problems 8 and 9, I want to talk about finding a common denominator. So when we are looking for a common denominator, here's how I think of it. I am looking at the larger of the two denominators. So I'm going to be looking at 8. I'm trying to identify how can I make 6 and 8 be the least common denominator. I could multiply 6 times 8, and you're able to do that, but you then would have to remember to reduce that fraction at the end. I ask myself, is there something that I can multiply 6 by to make it 8? And if I do, I need to also multiply that numerator by the same value. Well, there isn't anything that I can do. 6 times 2 makes 12. 6 times 3 makes 18. So there's no number that I can think of without it being a fraction or a decimal. So I don't want to do that. So what I'm going to do is double the number 8, double the larger number. So that would be 16. Can 6 times something become 16? Nope, that doesn't work. Okay, what if I triple that larger value? So 24. Can I multiply 6 by something to make it 24? Sure. 6 times 4 makes 24. So I'm also going to multiply 5 times 4. Now I need them both to be 24, so I have to multiply 8 times 3 and 2 times 3. So I would have 20 over 24 plus 6 over 24. Now when you're adding fractions, you keep the numerator. So we would have 26 over the common denominator of 24. Okay? All right, so let's look at a second example. Now this time I'm subtracting, but again, before I add or subtract, I need to have a common denominator. So looking at the larger value, is there something I can multiply 2 by to make it 7? Okay, there isn't anything that I can, so I'm going to go ahead and double 7. So that would be 14. So yeah, I can actually take 2 times 7 and make it 14. I can take 7 times 2 and make it 14. Now I will have 4 over 14 minus 7 over 14. So 4 minus 7 gives me negative 3. Keep the common denominator of 14. All right, let's try one more. So on this one here, if you wanted to pause the video and try to find that common denominator and then come back and check it, that'd be great. So here, I'm looking for, how can I make 4 6? 4 times what would make 6? Well, there isn't anything. What about if I doubled 6 to be 12? Yeah, 4 times 3 would make 12. 6 times 2 will make 12. So I would have 9 over 12 minus 2 over 12, which simplifies to 7 over 12. Okay. Now, finding the least common denominator is really important in these next problems that we're going to be working with. So we are also going to be using our properties of rational exponents and our properties of radical exponents. This was on top of the 5.2 notes. Okay, so here's the rules for rationals, and here's the rules for radicals. Okay. All right, so let's go ahead and simplify using the properties of rational exponents on this one. Show work, no decimal answers, which means you're going to have to leave them fractions. All right, so looking at number 8, we are multiplying two bases. They're the same base. So this one here, we are going to use the product of powers. Now, first off, they need to have a common denominator because the product of powers tells me that I'm going to add the exponents. So if I'm going to add those, I need to make sure they have a common denominator. So can I make 6 9? Well, nope, I can't. But can I make 6 18 when I double 9? Yep, 6 times 3, 1 times 3. I also have to make this one 18, so I'm going to multiply it times 2 and times 2. So I'm going to have 5 to the 4 over 18 power times 5 to the 3/18 power. Now I want to note something here. I didn't write this way. This here would be incorrect. Okay, the 4/18 is the exponent. 3/18 is the exponent. So when we have these ones here, now I can keep the base and I can add the exponents. So I will have 5 to the 7/18. Okay. All right, on number 9, we have 2 things actually happening here. On number 9, we have the quotient of powers, and we also have the power of a quotient because there's a power on the outside. Now, there's 2 ways that we can do this. I'm going to talk about the one where I simplify what's in the parentheses first. So I'm just going to look at this here, and then I will worry about the power on the outside. So first off, I've got to find a common denominator. 8 does go into 16 if I multiply it by 2. So when I rewrite this, I have 8 to the 14/16 over 8 and 1/16, still with the power of 1/2 on the outside. Now on the inside of the parentheses, I can subtract that now. I can simplify that so that I have 8 to the 13/16. And the power on the outside is 1/2. Now here we are going to use a power of a power where we are going to multiply the exponents. So I will have 8, 13 over 32. Okay. All right, we have 2 more to do, or 10, 11. I'm going to do 10. I'm going to leave 11 for you, and then we have 12 and 13. So on number 10, we cannot have a radical in the denominator. So in order to get rid of that radical, we are going to multiply by the conjugate. Conjugate means it's the same values, but the opposite operation. Okay? Whatever we do to the denominator, we have to do to the numerator. So now I'm going to use distribution and do 3 times 5. That gives me 15. 3 times radical 2. So that gives me positive 3 radical 2. And the denominator, we talked about we could FOIL the whole thing, but 2 of the terms would cancel out. And we also talked about the shortcut where we take the first times the first and the last times the last. Okay? So we have 5 times 5 gives me 25. A negative times a positive is going to be a negative. Radical 2 times radical 2 gives me radical 4, which simplifies to 2. So that gives me 15 plus 3 radical 2 over 23. All right, and I'm going to leave number 11 for you to try on your own and then check that one. Last ones I'm going to look for are number 12 and 13. We are going to simplify, assume that all variables are positive. So we won't have to worry about any plus or minus on these ones. We're just going to assume everything here is positive. Okay? All right, number 12. We are looking to make sure that they are both under the same root. The same radical. So they are both under the third index. They both have an index of 3. So we're going to go ahead and rewrite these first and combine them into one radical or one cube root. So 5 times 25 gives me 125. A to the first times a to the third, we add the exponents, so that gives me a to the fourth. B to the fourth times b to the fifth gives me b to the ninth. And c to the first times c to the sixth gives me c to the seventh. Okay. Now, if I wanted to then go ahead from there, I've got to see if I can simplify this further. Can we take the cube root of 125? Yes. The cube root of 125 gives me 5. Can I take the cube root of a to the fourth? This is when we talked about power over root. So 4 divided by 3. Well, we cannot do 4 divided by 3, but I can do 3 divided by 3. So if I had a to the third, I could do a to the third divided by 3, and that would give me a to the first. However, a to the fourth is 1 more than a to the third. So that means I have an a remaining underneath the radical. Okay, now b to the ninth. So I have the cube root of b to the ninth. 9 can be divided by 3, so that is b to the third. Then I have the cube root of c to the seventh. 7 cannot be divided by 3, but 6 could be divided by 3. So 6 divided by 3 would be 2, and there's still a c that's remaining, so that c stays under the radical. This would be my simplified form for that one. Okay. All right, number 13. Now this time we're going to look for the fifth root. We're going to look for the fifth root of 1024. We're going to look for the fifth root of x to the 20th, the fifth root of y to the fifth, and the fifth root of z to the 10th. If there's anything that we cannot take out, then that stays underneath the radical. So first off, the fifth root of 1024 is 4. The fifth root of x to the 20th, 20 divided by 5 is 4. So that's x to the fourth, and that stays in the numerator. Now we're going to move down to the denominator. So far, there's nothing left under the radical. Now I have the fifth root of y to the fifth. That gives me y to the first. And I have fifth root of z to the 10th, which is z to the second. This one had nothing left under the radical. If it was, it would have been over here. the radical would not still be over that information. That stuff was pulled out of the radical when we took the fifth root of it, okay? All right, so that is it for this video. Again, if you have any questions, please make sure that you're coming in for tutoring. Make sure that you're asking those questions so that we get this down before our test. All right, have a great evening.